Welcome to the last of these 8 sessions on this beginner series of Coding with Doc. Well done for making it this far. Now, I'll be honest, my favourite exercise of the lot, the one that any of you that have been teaching this outside of school that are watching this again, the exercise we're finishing with today is the best exercise for checking that you've understood it. It's a solid game, it's quite a useful algorithm for GCSE, and really you're doing a higher-lower guessing game where the computer's picking a number and you're trying to guess it in the minimum number of guesses. But the beauty of that bit of code is you've got to do a set of sequences, you've got to do some selections, and you've got to do some loops. So that's where we're heading in the Make challenge at the end of it. So as previously, we are going to be using the PRIM methodology in this final session. Now, in many ways, it's leading up to a make task, and it's probably my favourite make task of all the make tasks you'll have done in this section, because for me, it's a very practical test of have you understood sequences and selection and iteration, and it's a basic game and it works as a game, and so therefore it's quite interesting to do and play, etc. So we're going to do that. Now, as always, we'll begin with some predicts rather. We'll then do a couple of run exercises. We'll then have an investigate or two, and then having done those, we'll look at modifying something, which will then lead in nicely to this final make challenge. So that's the structure where we're about to go. Please can I get you to get those whiteboards or pieces of paper sorted, and the first thing I want you to do is just check how much you're understanding and simply fill in words into gaps. And I'll shut up for a little bit while you do this so that we can just fill what word goes in what gap and test your understanding of what we've been doing. So let's work through those answers. And if I'm going too quick at this point in time, of course, you'll just pause the video. So it starts with, when a computer program runs, it follows a specific sequence for executing instructions one after another. Sometimes we need programs to make decisions. This is where selection comes in, often using, now it doesn't really matter which way you put these three round, but I would have done if, elif, and else statements, because that's the order you'd have to put them in the program. If, elif, and else statements to choose different paths based on conditions. If we want to repeat a block of code multiple times, we use iteration. A for loop is best if we know exactly how many times we want to repeat, like counting through a list of items. On the other hand, a while loop is perfect if we want to keep repeating as long as a certain condition remains true, such as waiting for a user to enter a correct password. It's crucial to ensure that the condition in a while loop eventually becomes false. Otherwise, you end up with an infinite loop, which will run forever. To control how many times a while loop runs, we often use a count variable. And so that hopefully has given you that kind of set of options, and you've been through there, and we've managed to get that one done. Now, the next bit you're still going to need your whiteboards for. We're going to do some predicts. Well, a single predict, and then we'll move to a run. So the predict is this one. What's the code doing? What is it going to do? So again, if I'm going too fast at this point, just pause the video while you finish the answer. But print number checker is obviously going to put number checker on the screen. And then for the number in range 1 to 6, so that's going to go from 1, 2, 3, 4, and 5. It'll count up to 5. If the number it's on is divisible by 2 with no remainder, it's going to say it's even. Otherwise, it's going to say it's odd, and then the check's complete. So what's it going to do? It's going to check every number. So it's going to go 1 is odd, 2 is even, 3 is odd, 4 is even, 5 is odd. And that's how it will run and execute through. And so now, don't forget to subscribe. Now it's time to do a run challenge. Let's do this run exercise. So try and keep up with me. I'm going to code it out on the screen, and I'm going to put the code in, and I'm hoping you'll build it with me, and then we can explore it and look at it, etc. So we've done print secret word. Fine, we all understand what that's doing. And then attempts equals 0. Having done that, we're going to say correct word equals, let's stick with Python again. So we've done Python, and then input, or let's put guess equals quote quote. Now, while guess is not the same as correct word, and attempts is less than 3. Guess equals input what secret word am I thinking of? Question mark. Now, you could, if you wanted to, do a print before that went, you have taken attempts. So you've taken, and then whatever the number is, attempts. So you've taken 0 attempts in the first instance of what it's going to do. So we've got that. Now we want to be able to check if the guess is the same as the word. So there it's going to go if guess is the same as correct word. So if it matches, what do we want it to do? Well, in that we want it to go print access granted. You've got the right word. And then I want to do elif, otherwise if, attempts is the same as 2. What do I now want it to do? I want it to go print you are running out of attempts. Access will be denied. And then if that's not the case, again, you notice how each time around the if has to be inside the loop, but it's against the margin. So the first if is if it matches. The second is if that one's true. And then now the third one is what's going to happen if that one's true. So in this case, we're just going to put incorrect code have another attempt. And then still inside the loop, I want to do attempts equals attempts plus 1. So you've had another go. And then I want to put a print that says, welcome to the main program. So, a couple of questions here. How's the code doing what it's doing? Second one, what conditions need to be true for it to keep going? And then the third one, how does the elif work? So let's play with that. So it says, what secret word am I thinking of? And I put in Liverpool. And it says, incorrect code, have another attempt. You've taken one attempt. So that you've taken one attempt is that first print statement that was part of that one. The incorrect code is coming off this else. So I then put in, say, Bethan. And then it says, incorrect code, you've now taken 2 attempts. What secret word am I thinking of? Now, at this stage, if I put the right word in, it says access granted and lets me in. But if I run that again and do exactly the same thing, so I put in Liverpool, and I get my first attempt gone. Bethan, I get my second attempt gone. And this time round, I put in shoehorn. You're running out of attempts, access will be denied, but it still then lets me into the main program. Yeah, it's now said you've kind of run out of goes. Now, you can see it's not perfect, it's not wrapping back, but you're seeing how that if statement's working, how those indents are working to allow that to happen, and how we've got a sequence that's controlling that flow. So then let's take that and develop that a bit further. Pause the video at this point if you've not finished getting that down and you've not followed that one through yourself. So then that's enough of a pause. Now, let's now take and investigate. So one where we're changing it ourselves. Now here I want to play with the idea of a loop inside a loop, which is quite common on a clock and things like that. So for I in range 3, and then inside that, I'm now doing another loop for j in range 2. Now, what I'm interested in showing you is what's the order these are going to print in. So outside loop, print, outside loop is on, and then the outside loop is I. And then we can go, and the inside loop is on, and then we can do J. And you'll see what that then does as we run that, as you'll see how those work. You notice we've got 2 separate number counters. Now we'd have to call them different things. I've called them I and J, but you could have called them counter 1 and counter 2. It doesn't really matter. But watch what's happening. The outside loop's on 0, and the inside loop goes 0 and then 1. Then the outside loop moves up to 1, and the inside loop then does again another 0 and 1. And then the outside loop does a 2, and the inside loop does another 0 and 1. So now my core question is, can you modify that in order to make it a working version of a digital clock? I'll pause the video, or please pause the video while you have a bash at that. So then, if I wanted to tweak that to work for a digital clock, it's probably going to be easier to give these names that we'll recognize. So we'll say hours is in the range that goes to 24 hours in the day. And then we'll do minutes in a range that will go to 60 minutes in an hour. And then what we need is a third loop that's now on the inside of that, that's seconds in range. Now they're also in the range of 60. So at that stage, you've got the three of them. Now there's nothing to stop you doing that. So instead of now worrying about the inside loops and the outside loops, we want to make this look like a clock. So we say the time is. Now, the first thing we're going to want is hours. And the minutes are at minutes. And then you could do, and the seconds are, and then you could do seconds. Now, if you wanted to do the from time import, the one that we did earlier on, where you're importing from time import sleep, it was, and then you could do sleep of 1 second on each of these loops as you're going through. You could do that on this one and make a perfectly accurate clock. If I did that, though, it's going to run for 24 hours, and it'll be much longer than this video needs to be. But if I run that straight, just as that is, time to take all what we've just learned there and do a modify example where what we're doing is we're taking that code, we're playing with it, we're seeing how it works, we're pulling it apart a little bit, and we're just building up that confidence in working with that bit of code. So this is the modify challenge. Now on the modify challenge, what I'm wanting you to do is look back at the code that we did for the secret game code, and can you tweak it? Can you tweak it that it says too short if the guess is less than 6 characters, or too long if it's more than 6 characters, or incorrect if it is 6 characters but it's wrong, and then it stops it after 5 tries. Now you can see that while I'm doing a kind of a modify the secret code, it's almost like you're guessing the code. In reality, this is the sort of code that's behind most password systems at a very basic level. So I'm just trying to get you to grapple with that and solve that, and I'll run through the answer in a moment or two. Let's go through that modify game or that modify challenge. And so what we were wanting was, we've got a secret code and it's having to work it out. So in there, we want to limit the number of attempts somebody could have. So we'll set attempts to 0 to begin with. And then we'll have our correct word and we'll set that. And I'll stick to Python, but clearly you can pick any word that you like. And I'll put in the guess as being blank to start with. So we've just created a kind of a basic start. And then we do while the guess is not equal to the correct word. And the attempts are less than. Now, we said the game should stop if they get it right or after 5 incorrect tries. So that's less than 5 tries. Now, we then allow them to make a guess. So we say guess is an input and then say enter the secret word. Now, you could do guess equals guess dot lower or upper, which always converts it to lowercase or uppercase, or if I did that and left it like that, it would be impossible to do. So we'd have to change Python to lowercase there. So that if you wrote Python in uppercase, that would change it to lowercase, and that would stop them using uppercase by accident. Now we can then go, if guess is the same as correct word, print access granted. Then we can add a new line and we can say elif attempts is less than 5. We can say, if that's the case, we're going to say print you have had the maximum number of attempts. That will do that one. And then we can do the else. And now inside the else, we can now do another question. So we can do size is the length of the guess. And then we can go, if size is bigger than 6, print this had too many letters. And then we can do elif size is less than 6. And we can go print this had too few letters. And then we can say else. So there, it's not bigger than 6, it's not less than 6, and Python's the right word. We can say print right length, but the wrong word. And then the only thing we need left in the loop, now you'll notice I've come out of that loop with the else, and then I'm back to the main while loop now, and we say attempts equals attempts plus 1. Now there is a quicker way of doing that. I'll put it onto the hashtag, and some of you might want to learn these fast ways, and some of you might think I'm not bothered, but that's attempts plus equals 1, and that means exactly the same as what I've just put there. So those two work in exactly the same way. Now I think that's an answer to what we've just been done. So if I put in there Liverpool, it's going to go, I've had the maximum number of attempts. Well, that's wrong. It's because my less than and my greater are the wrong way around there. So if I stop that, run it again, and this time around I put in Liverpool again, it said this has too many letters. So now think of a 6-digit word. So now right length but wrong word, and now I put in Python and it says X is granted. So that's working as a solution. So we've got to what I think is the best of the make challenges on the whole of this beginner exercise. What you're doing is you're picking a number, the computer's picking a number, so you can't cheat, you don't know the answer because you've coded it, and you're trying to guess it in the minimum amount of guesses. And it will simply tell you whatever you put in, higher or lower, higher or lower. Now really, that type of program is at the heart of one of the algorithms that you use at GCSE. It's a searching algorithm. Now, searching and sort are great areas to get into because there are lots of businesses that need to be able to sort a set of data and to be able to search a set of data. And the beauty of this is not only is it useful for real life in terms of how we do search and sort, but it's also useful for you now because it's a coding challenge. It's got sequences in there, it's got selection in there, and it's got loops in there, it's got iterations in there. And you can choose the type of loop you do, and it'll test how well you've understood all of what we've done. So let's get to it, but as always, don't forget to subscribe. This is the task we've been building up for. So what I want to do on this is build actually what I quite enjoy as a game. I want to be able to use that kind of idea of import again. Now, we're going to need to import the idea of randomness. And what we want it to do is to make a number that's a random number that we don't know, so we can't see it in the program code. It makes a random number between 1 and 100. And to do that, you'd use the command, whatever the variable name is. I've called it a numvar, but you could call it X or guess or whatever you wanted. equals random.randin 1 to 100. And that will make that a random number. And then what I want it to do is very simply let a player guess what number it is. And if the guess that they make is too high, it should tell them to guess lower the next time round. Whereas if they guess too low, it should tell them to guess higher the next time round. If they've guessed correctly, it then should exit and tell them how many attempts they took to do the number. Now, I think this is a brilliant make challenge. It tests your sequences, it tests your selection, it tests your choice of iteration. It's a really good drawing together of all the things we've learned over the past 8 sessions. Now, see if you can do that one on your own. Create random numbers. Then we're going to want to have some variables. So we're going to want to have a variable called guess, and we'll set that to begin with to 0. And we're also going to have a variable which is going to be the actual number. I think on the slide I called it numVar. Yeah, but you could call it anything you liked. Yeah, you could call it actual number or number variable or whatever you want. Yeah, and we use the command there random.randint between 1 and 100. So it makes it be between 1 and 100. So that gets us started. And then I think the next thing we need is the ability to make a first guess. And then what we need is a loop that checks if we've guessed it. And then inside that loop, we need an if statement for higher or lower. And fundamentally, that's it. You might want some sort of print at the end of the game. So that's the structure of what we're going to make. So now let's look at how we would do that. So how do we make a first guess? We go guess, because that's what we've set it to, guess. In fact, let's do a basic print to start with before we do that says, welcome to the number guessing game. And then we got another print that says, I am thinking of a number between 1 and 100. Print, see if you can guess it in the smallest possible number of guesses. So we've got that, and then we do where I was going to go originally, but we've now got at least some sort of start that's getting us going. So we've gone guess equals an integer input that says, what number do you think it is? Now, what we've done there very deliberately is let them take a first guess. Now, we might want to have number of guesses, and we'd set that to 1 because we're going to build that in as the 1 there. So when it comes to a loop, we've got a choice now. Now, of course, on that guess, before we go on to the choice, you could have just done an input and then do guess equals int guess if you'd wanted to separate out the int and the input onto 2 separate lines. But I guess most of you probably will get used to doing it like I'm doing it there. Sorry, back to the loop. Now, when we're on the loop, we've got this decision to make. Are we doing a for loop where we know how many guesses it's going to take, or are we doing a while loop where we don't know and we know what the condition is for it to be right? And clearly that question answers itself. We're doing a while loop. So we say while guess is not the same as, exclamation mark equals is not the same as the number variable that it's come up with. So we don't know what the number variable is. We do not guess it. The person typed in a guess at this point in time. So while they're not the same as one another, what do we want to do? Well, we want this if statement to work. So I'm going to put that hashtag up in a minute, but we're going to go if guess is bigger than numVar. What do we want to happen? If it's bigger than it, we want to print that guess was too large. It's bigger than it. What's the alternative? Else print that guess was too small. Now, there might be some of you that did elif, that guess was too small, else the guess was the same. But that's kind of pointless because on 15, if guess and numVar are the same, it's not going to do this loop. It's only when they're different that it's going to do this. So it's either too large or too small. Yeah, that guess was too small. Let's get the English of that right. Now, for both of those, when they do that, what we want to do is number of guesses equals the number of guesses plus 1. A quicker way of doing that is to do number of guesses plus equals 1. And that does exactly the same as the line above, but I'm going to take that out. Yeah, but it's just a quicker way of doing it. So there you can see my little if statement that's going to go with that is going there. Yeah, so that's that one. And then now it's going to keep going around that loop until we get it right. Now there's a problem here. If we just run that at the moment, we'll type in the first number and then it'll go, if it was too large, it'll go, that guess was too large, but it'll just keep repeating it in infinity. Or if it was too small, that guess was too small, repeat it in infinity. What we've got to do is to give it inside the loop chance to make another guess. Because if you forget to do that, it'll just get trapped in one of those endless loops that I was warning you about in one of those earlier sessions on the loops. So what number do you now want to guess at? Now remember, if they get this right, it'll exit the loop. Yeah, if they get it wrong, then it'll do the higher or lower and it'll add one to the thing. And so then we go print. So now this is out of the loop. So back to the margin. Yeah. So we've now guessed the number and we say, well done, you guessed the number as, and then let's put in numberVar. So we've put in what the number variable is. And at this point then, we can say print, it took you number of guesses, attempts. It took you 6 attempts, it took you 5 attempts, whatever. So we've got that. That gives us the code. There, the code is all running. So we run that. Now, if I just save it to start with, we run that. And it goes, welcome to the number guessing game. I'm thinking a number between 1 and 100. What number do you think it is? Now, if we were doing a binary search at this point in time, the best place to get is not 1 or 2 or randomly. The best place to go is always the middle. So 50. That number was too small. Now where do you want to guess at? So we go 75. Split it in half again. That number was too small. Now you can see now in 2 guesses, I've halved the number of possibilities from 100 possibilities to 25 possibilities, halved and halved. Yeah, so we've got the number right down. So now I want to guess at really 62.5, but I can't. So I'm going to plump one side or the other, and I'm going to go 62 and hope I get lucky. I didn't get lucky. It was too small. It's on the wrong side. So now I've got a number between 62 and 75. So halfway between those two is about 60. Well, 68 is, yeah, it's not great, but that number's too large. Well, that's helped us. So now it's between 62 and 68. So you could guess at this point at 65 too small. So it's up from 65, it's between 65 and 68, so it's 66 or 67. So at this stage, I'm guessing 66. Well done, 26 attempts. Now, see if you can make that piece of code, see if you can beat me in terms of the number of guesses, and well done for making it to the end of the course. I trust you've enjoyed it so far. I trust you've learned something. I trust you come back for some of the other sessions that we'll do.